My name is Brian Gall, and welcome to Bits, Bytes, and Binary, a presentation from the Tech Dawgs at Southern Illinois University. Let's start with the big question. What is binary, and why do we need it? In the field of computing, binary is a counting system made up of only ones and zeros. In everyday life, we think of the standard counting system as including numbers 0 through 9. However, the binary counting system only has two numbers. Computers store data and calculations as strings of binary numbers. In those cases, 1 means on or true, and 0 means off or false. It is important to know and understand binary because it is the language of computers, also known as machine language. That is why all calculations, operations, and communication within a computer rely on binary at the most fundamental level. So what is a bit? A bit is a basic unit of data. 1 means on, 0 means off, 1 is equal to true, and 0 is equal to false. So what is a byte? Bytes are composed of bits. So 1 byte is equal to 8 bits. 2 bytes is equal to 16 bits. 3 bytes is equal to 24 bits, and so on.
Bytes are formed in a metric system. As you can see in this chart, we consider bytes at different levels. A kilobyte, a megabyte, which is 1024 kilobytes, gigabytes, which is 1024 megabytes, and so on forth. The pattern continues to pretty much infinity, but here's an example of just some of the ways that we call bytes. So then, now that we understand what a bit and a byte is, how do we use binary? It's simpler than you think. We can convert binary to decimal and decimal to binary. In this example, we are going to convert binary to decimal. The decimal system, the system that we normally use, is shown here. Consider the number 255. Now let's break that down. 5 is in the ones place, another 5 is in the tens place, and a 2 is in the hundreds place. If we spread that out, we can think of this as 2 times 10 to the second, which equals 100, plus 5 times 10 to the first, which is 10, plus 5 times 10 to the 0, which is 1. So now you have the ones place, the tens place, and the hundreds place. Together, you can add these all up, and it creates 255. We can do the same thing in binary. Let's take the same number, 255. Now in binary, we write 255 as 8 ones. But we apply the same method. So what we can do is, using the base of a 2 rather than a 10, we can say 1 times 2 to the 7th plus 1 times 2 to the 6th plus 1 times 2 to the 5th, and so on forth. If we add these numbers all together, we end up getting 255. That is how the binary system works. It's very similar, but it's only with the base 2. Now, what if we want to move from decimal to binary? When we do this, we divide by 2 and keep the remainder. Consider the number 100. Let's go through the process. 100 divided by 2 is 50. Is there a remainder there? No. So we say 0. 50 divided by 2 is 25. Remainder, 0. 25 divided by 2 is 12. We have a remainder of 1 because 12 goes into 25 2 times, giving us 24, but with a remainder of 1. Now, 12 divided by 2 is 6. We have no remainder, so 0. 6 divided by 2 is 3. No remainder. 3 divided by 2 is 1, with a remainder of 1. 1 divided by 2 is 0, with a remainder of 1. And 0 divided by 2 is 0, remainder 0. So, in binary, 100 is shown as 0, 1, 1, 0, 0, 1, 0, 0. That's how you can convert from decimal to binary. In conclusion, binary is a pretty basic system. It's the way that a computer works, and it's how it communicates and creates calculations correctly within the computer. This method that we use to convert decimal to binary and binary to decimal is the basic way that we can move from our normal system into binary, the language of the computer.